knowledge and wisdom to solve our mathematics problems and our daily life problems. Thank you, God. Right, let's move on to the topic. In that first example is if f maps are to R such that f of x is equal to x square plus 5x plus 9, then find f inverse of 8 and f inverse of 9. So first, whichever is there, that equation you can write. What is that equation? F of x is equal to x square plus 5x plus 9. So f of x is equal to x square plus 5x plus 9. So what I need to find? F inverse of 8 and f inverse of 9. So let me go for f inverse of 8. So f inverse of 8 is equal to x. And here same method, another also you can write f inverse of 9 is equal to x. So here inverse, when it goes to that side, f of. So 8 is equal to f of x. Same method, 9 is equal to f of x. And you already know what is f of x. So f of x is nothing but x square plus 5x plus 9. F plus 8 is equal to that side, minus 8. So x square plus 5x plus 9 minus 8 is equal to 0. Then we can write x square plus 5x plus 1 is equal to 0. 9 minus 8 is nothing but 1. So now it is in the form of x plus c is equal to 0. If any in the form of ax square plus bx plus c is equal to 0, what are the roots? Roots formula is x is equal to plus or minus. So you can say b minus b plus or minus square root of b square minus 4ac upon 2a. So this formula apply and get the roots. So how to get the roots now? Then what is a here? Nothing is there, means 1 should be. So a is equal to 1, b is equal to 5, compare this all, and c is equal to 1. So b is 5, c is equal to 1. Just substitute those values here. So what I can write here, x is equal to minus, b is nothing but 5, so minus 5 plus or minus square root of b square minus 4ac. b square means 5 square is nothing but 25 minus 4 into a into c. 4 into 1, 4, 4 into 1, 4. So you get answer as here 4. So because 4ac, so a is 1, c is 1 and 4. So 4 into 1 into 1 you get as 4 upon 2 into a. 2 into a is nothing but 2 into 1, 2. So that is x is equal to minus 5 plus or minus square root of 25 minus 4 is nothing but 21. So upon 2. So now we can write it as here x is equal to minus 5 plus 2 root 20, minus 5 plus root 21 upon 2 comma minus 5 minus root 21 upon 2. So now what is your answer for this? What is your f inverse of 8? Last, f inverse of 8 is equal to half common minus 5 plus root 21 comma half minus root 21. So that is about your f inverse of 8. So this is again, understand this. So here x is equal to minus 5 plus root 21 upon 2 minus 5 minus root 21 upon 2. Now we can write f inverse of 8 is equal to half, means half common minus 5 plus root 21. Inverse of 8 is equal to half common minus 5 plus root 21, again half minus 5 minus root 21. This is about your f inverse of 8. Now let's move on to the f inverse of 9. So 9 is equal to, what is f of x? X square plus 5x plus 9. Plus 9, go to that side, minus 9. So 9 minus 9 is equal to x square plus 5x. So 9 minus 9 is 0, then x common here, x plus 5. So x is equal to 0 or x is equal to minus 5, because here plus 5, go to that side, minus 5. So x is equal to 0 or x is equal to minus 5. So at last we can write f inverse of 9 is equal to 0 comma minus 5. So this is about f inverse of 8 and f inverse of 9. So I hope so you all understood clearly. So let's move on to the next topic. Next, move on to the next question. If f maps are to a such that f of x is equal to x square plus 1, then find f inverse of minus 5 and f inverse of 26. Like previous method, how it is, same method only we have to solve. So first, what I need to write here, f inverse of 5 is equal to x. So 5 is equal to, then again we'll write 5 is equal to f of x. So after writing that, 5 is equal to, what is your f of x? X square plus 1. So write that x square plus 1. So after writing this, what we can write? Plus 1 comes to your minus 1. So 5 minus 1 is equal to x square. So 5 minus 1 is nothing but 4 is equal to x square. Okay, sorry, here you are observing that it is minus 5, it is not plus 5. So now I can write here minus 5, minus 5, minus 5, minus 5. So now minus 5 minus 1 you get as minus 6. So then x is equal to, your square is there, go to that side, square root minus 6. Square root minus 6 is nothing but imaginary number. So it is not belongs to the, x is not belongs to the R. So that it is not defined. So let move on to the next one. That is f inverse of 26 is equal to x. Then we can write 26 is equal to f of x. And then 26 is equal to, what is f of x? X square plus 1. Plus 1 comes to your minus 1. 26 minus 1 is equal to x square. 25 is equal to x square. Then we can write it as x is equal to square root of 25. So x is equal to square root 25 means plus or minus 5. So at last, what is your f inverse of 26? So f inverse of 26 is equal to minus 5 comma plus 5 or plus 5 comma minus 5. So this is about your second question. So here if f maps are to a such that f of x is equal to x cube plus 2, then prove that if we say bijection, find inverse function of f. What is bijection? First we need to prove f is 1 to 1, then we need to prove f is on 2. So first what I need to think it is, let x1 comma x2 is belongs to R. Then I'll write to find onto, to find 1 to 1 first. So if you want to find 1 to 1, f of x1 is equal to f of x2, right? So what is f of x1 means, wherever x is there, x1 substitute. So f of x is x cube plus 2, so x1 is there means x1 cube plus 2. And here also x2 cube plus 2. Now 2 get cancelled. X1 cube is equal to x2 cube, cube cancel. X1 is equal to x2. So if x1 is equal to x2 is there, then we can write therefore f is 1 to 1. So 1 to 1 proved. Then next one, on to we need to prove. So how to prove on to, just observe this carefully. I already said for you previously steps. So in that way we have to do now. So let y is equal to f of x is equal to x cube plus 2. So first write y is equal to f of x. Second write y is equal to x cube plus 2. Okay. So now here we can write this as f inverse of y is equal to x. Then here solve for the x. So now here plus 2 comes to your minus 2. Y minus 2 is equal to x cube. Then your cube is there comes to here. Y minus 2 whole power 1 upon 3 is equal to x. So now this gives as equation number 1. This gives as equation number 2. This x value substitute in your equation number 1. 2 in 1. So what is going to be happening? F of x is equal to x cube means x means this now. Y minus 2 whole power 1 upon 3 whole cube. So plus 2. Now 3 get cancelled. We can write y minus 2 plus 2 minus. Right. So at last what is here? You got f of x is equal to y. So that means therefore f is on 2. So therefore f is on 2. Once if it is on 2, now what is your f inverse of x? So f inverse of y is equal to what is here? X. So write that part. F inverse of y is equal to x means what do you know? Y minus 2 whole power 1 upon 3. Just remove y and write in the y place x. So replace y with x. So then f inverse of x is equal to x minus 2 whole power 1 upon 3. So first we proved it is 1 to 1 and 2. Then we found the inverse function, that is f inverse of x is equal to x minus 2 whole power 1 upon 3. That is about your third problem. So here given our next question is this: f maps q to q and g maps q to q such that f of x is equal to x, g of x is equal to x plus 2. Then show that g circle f whole inverse is equal to f inverse circle g inverse. So here you are understood that here f and g are two linear functions. You are observing that linear functions. So then f and g are bijections, so that f inverse and g inverse both are exist. So now what is your f inverse? F inverse also q to q, g inverse also q to q, because these are linear functions. And now what is your f inverse of x? So f inverse of x is equal to, we can write as x upon 2, and same method g inverse of x is equal to x minus 2. You may ask sir how it is. So it is, we can write f of x is equal to y is equal to 2x, and 2 here multiplying, go to that side division, so that y upon 2 means, so here f of x is equal to y, that is nothing but 2x is equal to y, x is equal to y upon 2. So then you already know that f inverse of y is equal to x. So then f inverse of y is equal to, what is x here? Y upon 2. So now here just in the y place replace with x, so that f inverse of x is equal to x upon 2. In this way you get here f inverse of x is equal to x upon 2. Same method, similarly g circle x is equal to x minus 2. So that is about how you will find f inverse of x and g inverse of x here for every x belongs to q. Here also for every x belongs to q. So what we can say after that? So this gives us equation number 1 and this gives us equation number 2. So then we know that composition of two bijections is a bijection. I already said to you these properties you have to remember. So we already discussed the important properties. In that, one property is that it says in this way, that is composition of two bijections is a bijection. So what I can write now here, therefore G circle F such that Q to Q is also bijection, is also bijection, is also bijection, and its inverse also bijection. So what is it inverse? You can write G circle F whole inverse such that Q to Q. So at last what we can write? Bijection, its inverse exists. So G circle F whole inverse is equal to Q to Q. So this is about another manner we can read this as G circle F whole inverse Q maps to Q. So that is about this, and how to find now G circle F whole G circle f of x. So now G circle f of x. So we can write G of f of x. So G of, what is your f of x? 2x. So now G of x means x plus 2. If G of 2x means x plus, I need to substitute 2x. So now 2x plus 2. So now you got as G circle f of x is equal to 2x plus 2. Here G circle f whole inverse is exists, so that what is your G circle f whole inverse, like previously how we find f inverse f x is equal to x upon 2, same method. When you solve, you get, therefore G circle f whole inverse is equal to, we can write x minus 2 upon 2. X minus 2 upon 2 for every x belongs to Q. This gives us equation number 3. So I hope you all understood up to here. So now you just understand, after completion of this, you found G circle f whole inverse, that is x minus 2 upon 2. If you find this, then automatically you already know one property. It says that G circle f whole inverse is equal to f inverse circle G inverse. So directly we can write, therefore f in G circle f whole inverse is equal to f inverse circle G inverse is equal to, what is that? X minus 2 upon 2. But if you want to solve this like f inverse circle G inverse also, we can solve. Okay, let's check that also. F inverse circle G inverse also x minus 2 upon 2, how it is. So let's revise again this, what it is they said, that show that G circle f whole inverse is equal to f inverse circle G circle G inverse. So now first f in, see here it is, you are observed that f of x is equal to x, G of x is equal to x plus 2. Here both are linear functions. So because of that reason, both are linear functions. Because of that reason, these both are 1 to 1 and onto. If 1 to 1 onto is happened, then f inverse and G inverse both are exist. That's what here written, f inverse Q maps to Q and G inverse Q maps to Q. Then what is your f inverse of x is equal to x upon 2 for every x belongs to Q. How to find f inverse of x is equal to x upon 2, I was explained clearly. So you just pass that and you can understand it. Similarly, what we done, G inverse of x is equal to x minus 2 for every x belongs to Q. Given equation 1 and equation 2. So now what here it is, if these functions are defined, then automatically therefore G circle f is Q to Q also is a bijection. Why it is a bijection means, it is already we learned in your previously, that is, if F and G are bijection, then G circle F is a bijection. If G circle F is bijection, its inverses exist. Once if its inverses exist, what we can write, G circle F whole inverse is in maps Q to Q. So now how to find this? First find the G circle F of x. So now G of f of x, we can write f of x means 2x, then G of x means x plus 2, wherever x is there substitute 2x, so that you write here x plus 2x plus 2. So now when you get this same method, how you find f inverse of x is equal to x upon the same method we found that therefore G circle f whole inverse as x minus 2 upon 2 for every x belongs to Q. So this is about how to find G circle f whole inverse x minus 2 upon 2. And here I written here, last time I said to remember you some properties. In that last property is that G circle f whole inverse is equal to f inverse circle G inverse. So that directly written as G circle f whole inverse is equal to f inverse circle G inverse is equal to x minus 2 upon 2. But if you want, again I am solving this f inverse circle G inverse, how it becomes as a x minus 2 upon 2. Okay. Let's move on to this f inverse circle G inverse. So of x is equal to, you can write f inverse of G inverse of x. So f inverse G inverse of x. So write here f inverse. What is your G inverse of x? You found that x minus 2. So write that x minus 2. It is from 2. Now f inverse x minus 2. What is f inverse of x? X upon 2. So we can just substitute in that place. We can write it as wherever x is there, x minus 2. So x minus 2 upon 2. So here this is from 1, means that is you substituted there and you got this. So and here for every x belongs to q. So now this gives us equation number 4. From 3 and 4 we can write g circle. We can write g circle f whole inverse is equal to f inverse circle g inverse is equal to x minus 2 upon 2. You just observe here also x minus 2 upon 2, here also x minus 2 upon 2. So that is for every x belongs to q. So you are understood now how that property is true. So that property, it says that what? G circle f whole inverse is equal to f inverse circle g inverse. So now property also proved, your solution also proved. So this is about our textbook examples. This is about our part number 2 completion. If you have any doubts, kindly comment on the comment section so that I will clarify your doubts. So let's next video we are going to discuss exercise number 1.2. Okay, so kindly take care of yourselves, stay in your home, that will be good. God bless you all.